In this problem, again we want to find the equation of parabola. This time we're told vertex is at the origin, so it's going to be in that form, x squared is equal to 4ay. The only other piece of information we're told is that it passes through the point minus 4a. Now remember, when we try and solve this, really to find the equation of the parabola, all we need is the focal length. Now, what we need to do is find a value for a. The piece of data that allows us to help us is the minus 4a, because if it lies on the parabola, it must satisfy the equation. When we substitute minus 4 in there and 8 there, it must satisfy this parabola, this equation, because it lies on it. So if that's the case, it allows us to create an equation where our only unknown is a. So we substitute the minus 4 in, substitute 8 in, we end up with 16 on the left hand side, 32a on the right hand side, which leaves us with a value of a, which is a half. Now we know our equation is x squared is equal to 4 times the half times y, where a is the half there. And so that gives us an equation of x squared is equal to 2y. So again, if you're not sure if that's correct, substitute minus 4 in, substitute 8 in, your left hand side and right hand side should be equal. In this problem, we look at the equation of the parabola again. All the vertexes in these problems are at the origin. This time we're told the equation of the lattice rectum is minus y is equal to minus 1. Now, what we need to do is, again, find the value of a. We know that the equation of lattice, if the equation of lattice rectum is y is equal to minus 1, we know that lattice rectum is a special chord that goes through the focus, but it's also perpendicular to the axis of the parabola, parallel to the x-axis, perpendicular to the axis of the parabola, in this case the y-axis. If it goes through minus 1, that means it must go through the focus as well. So we can say that the focus has the coordinates of 0, minus 1, which means our focal length must be 1 unit away from the vertex, because that's minus 1, it's gone down 1 unit, the vertex is the origin, so there's 1 unit between it. A must be equal to 1 then, in this case. Do that substitution. Because it's concave down, it's going to be a minus 4. It's going to be in that form. It's minus 4 times the 1 times y, which gives us x squared is equal to minus 4y. In this problem, we're told the equation has a focus at 0, minus 3, directrix at y is equal to 3. Well, if we draw that up, we can see that we've got a focus down here. So there's our focus at 0, minus 3, which means, because it's that, the y-axis must be the axis of the parabola, because the focus lies on the axis of the parabola. Directrix is y is equal to 3, so it means it's above there. If that's the case, then we know the direct distance between the focus and the directrix is, if we half that, find halfway between that, that gives us our vertex, which means our vertex is sitting on the origin, which means we can use the form of x squared is equal to 4ay. So that's all. That's not a problem. We can use that form. So again, all we need to do is find a. Well, if we know that the focus is 0, minus 3, we know that a from that must be equal to 3. And so we can do the substitution in. Because the focus is below the directrix, we know it's concave down. So if the focus is above the directrix, it's concave up, but focus is below the directrix, concave down, which means it's in this form, minus 4 times the 3 times y gives us minus 12y. It's all about getting that value of a. So in these situations, we're giving the focus, we're giving the parabolas this time, and what we need to do is just calculate the vertex and focus. Well, if it's in the form x squared is equal to 4ay, if it's in this form, we can say that the origin is the vertex is at the origin. So every time it's like that form, we know that's true. Then the next point is to say, okay, well, to get the focus, we need the focal length. To get the directrix, we need the focal length. From x squared is equal to 4ay in this form, 8 must be equal to 4a. So if 8 is equal to 4a, it's easy to see that a must be equal to 2. So if that's the case, it's concave up. Focus must be 2 units above the vertex. Directrix is 2 units below the vertex. So we're able to write it in that form. In this case, if we look at y is equal to minus x squared here, we can write it in this way. So actually we can, if you're looking here, it's actually got a bit of a problem because we've made an error in this case. It should be, this should actually be x squared is equal to y on 7. So if you change that, and we can see that it's in that form, but then 4a, because it's x squared is equal to 4ay, 4a is actually going to be equal to 1/7. We divide by 4 there, gives us a focal length of 1 on 28. Again, because it's in the form x squared is equal to 4ay, we're able to see that 4a would be the 1 on 28, or 1 on 7, which gives us the 1 on 28, and the vertex is at the origin. It's negative, so it's concave down, so our focus has to go down below the origin, and our directrix rises above it. So we get the 1 on 28 below, and the 1 on 28 above.